All right, guys. So as I was saying before we were interrupted. Now, as I was saying, if we are to represent some data using a pie chart, first we need to get the data in a table. And the table will tell you the portion of the data that is allotted to whatever you're sharing in the data. So in this table, you notice that the data type or the type of data is about transportation. And the table specifies 3 types of transportation. So you have other methods, you have bus, you have private motor. So these are 3 modes of transportation that this data is representing. All right, now the right column tells you the number of these portion of data. So what we can consider the right column as, it would be, or we refer to as a distribution or a frequency distribution of the data. Anybody know what the word frequency means, Ms. Waysom?
The amount of time the number is used, sir.
All right, so the amount of occurrence of something, that tells you the frequency. How many times it occurs, tell you the frequency. So based on this table, the numbers using would tell you the frequency here. So for instance, for other method of transport, you would see from the table that the bus method, no, not the bus, but other method, you would have 1,560 persons would opted to use other methods of transportation. For bus, you would have 840. For private motor, you'd have 330. Now, these would be data collected in terms of transportation, but then now it is now sorted in terms of different categories of transportation, which is other methods, bus and private car. Now, so the data on a table don't really give us much of a good picture of what is happening, but if we can put it on a chart or a graph, we can see a much, more clarity by way of a picture of what is happening with the data. All right. Now, so from this table, it would be necessary for us now to find a way to represent this data on a pie chart. And we say that the pie chart is circular. And so we would like to draw a circle. And for this purpose in math, we are not just going to use a pencil to sketch a circle, but rather we have to use a compass so that we can get a perfect circle. And so when we are measuring angles, the angles have to measure correctly in order to get the right portions in terms of the representation, because we are not just estimating the portion, but we want to use correct measurement to get the portions in terms of the various sectors. All right. Now, in order for us to do that, we first need to decide what are we going to use, whether or not we're going to use the sector angles to do the portions, or we're going to use sector areas. Now, both of them, if we're using sector angle or sector area, both of them initially we will have to calculate the angles of the data. Now, if you look at the data now, and we're going to represent the data based on sector angles, now we should bear in mind that a circle, a full circle, would have an angle of what? What would be the measure for the angle of a full circle? Miss Green. The angle of a circle, a full circle is measured what?
360 degrees, sir.
Yes, 360 degrees, right? And everybody by now should be familiar with that. Because if you start at one point with a radius from the center and you spin that radius going around like the hand of a clock, when it comes back to the starting position, it would have completed 360 degrees. And remember, angle, anybody remember what an angle is? Mr. Wilson, what is an angle? What's an angle, Mr. Wilson? Give me a second. All right, sorry about that, guys. So I was asking about what does I ask about the angle of a circle, which is 360. So now our task is now to share that 360-degree angle among these data. Now, remember we say earlier on that the total data is represented by the entire circle. So if the total data is represented by the entire circle, then first we would have to calculate what is the total data that we have here. How can we go about calculating the total data? Ms. Williams.
Sir, what's the question, sir?
How would you go about calculating the total data here?
I'm not sure, sir.
Mr. Paisley, how do we go about calculating the total data?
Add up all the modes of transportation, so
Right, so you just add up all of the numbers in the right column, and that will give you the total data, because remember, each of these numbers tell you how many persons would use these different modes of transportation, right? So the total number of persons that use all transportation would be the sum of all of the data in the right column, all right? Now, the other question now, if when we add this, you get the sum of all the data, and that is the total of the data, how would we now represent these in terms of portions of the data? And we are thinking about representing them in sector angle. How would we decide what portion or what angle these data are going to represent? Ms. Cavera.
Sir, I think basically when you like divide them, I think the way would have set up is that the other motors would I have a bigger portion of the pie than the bus and the private motor.
All right,
Is that
so that is quite obvious from the table, but in terms of how would we calculate the angles representing those portions?
I guess you would subtract home after you add up all of these, I guess you're gonna like subtract how much out of all. Well, that basically done shown. I don't know, sir.
All right. Mr. Ajeno, give me,
Divide them
when you said divide them, what that means?
by 360.
You sure that's what you want to do? All right. Miss Clark, how would you calculate the angles of the sectors representing these data or the data?
I don't know.
This way some?
Not sure, sir.
Okay.
Sir, are you talking like percentage, that the data could be represented in percentage?
No, in terms of angle, not the percentage. How you do it for the angles? All right, Ms. Cabrera, you have made a good point though. How would you do it for percentage?
Basically, I don't remember if I calculated.
Remember, now guys, remember we're drawing closer to exam, so you need to sharpen up your skills with these other topics that we would have gone through already. All right, Mr. Paisley, anything?
No, sir.
This way, somehow do we calculate percentage?
Sir, for instance, you'd have for the so the total, you have the total and you want to calculate the portion for other methods, so it'd be 1560 over the total times 100/1.
Exactly. So when you do that, you would be finding what fraction of 100 you would need. That's what you do when you're calculating percentage. You put the portion as a fraction of the total times 100. So how you think we're going to do it for the angles now?
So, sir, would it be the portion over the total times 360/1?
Exactly. So I hope you guys all understand that. Mr. Paisley, did you get that clearly what Miss was?
Yes, sir.
All right. What about you, Miss Cabrera?
Yes, sir.
Miss Williams and Miss Clark. All right. So that's how we're going to calculate the sector angles. And so first we need to add up all the portions to get the total, because we know that the total will represent the full circle. Now, the sector angles now, for us to calculate them, we're going to calculate for each portion. And to do that, we put each portion as a fraction of the total times 360. And from this, you notice that for other method, we would have 1560 over 2,720 times 360. And when you do that calculation, you will get a sector angle of 206 degrees. And if you do it for the bus, you'll get 101 degree, 111 degrees. And if you do it for the private motor, you will get 43 degrees. Now, what that would have meant is that you would have shared the entire circle into these portions of angle. So you know the entire circle has 360 degrees. And if you share that 360 degrees into the various angles that we calculate here, then we can use those angles when we are representing our sectors. So each sector will have one of these angles. And so based on what we have here, we're going to have 3 sectors. So in other words, the circle is going to be cut up into 3 slices, and each of these angles going to represent a slice. All right, so when it comes on to sector area now, remember now, if up here we are finding sector angles, to find the sector area, we could use the angles times pi r squared. So the angle over 360 times pi r squared, because remember, the area of a circle is pi r squared. And if you're using the angle to tell you the portion of what area, then you'd write that angle over 360 as a fraction of 360 times the area, and you will get the calculation. Now, as you noted, the calculation wasn't done. So I'm going to ask you now, take a screenshot and make sure that you can construct a circle with a radius and try to do the calculation using this, all right? That is for sector area. Now you can do that later on as an assignment, all right, guys? So just take a screenshot of it. All right, moving along. Now this is a video. This is a video that illustrates how we actually use the protractor. Anybody know what protractor is? We talk about compass and we talk about protractor. Anybody familiar with the parts in the geometry set? Anybody know what the protractor is?
Yes, sir.
All right. Can you describe the protractor for us, Mr. Paisley?
Semicircle plastic thing, sir.
Right. So that half circle that is used to measure angle, right? So that's a protractor. What's a compass again now, Mr. Paisley?
The needle thing, sir, for dry circle.
All right, remember you have a compass and you have a divider. You have to distinguish the two of them. Which one of them is a compass and which is a divider?
The one with the slot to put your pencil, sir.
All right, so the one with this, the pencil holder, that one is the compass, and the divider is the one that has 2 points, pointed ends. The divider is used to measure sectors. You can share up the sectors, or you can share up the arc of a circle. All right. All right. This video here is illustrated. You may not hear the volume very well, but you may be able to see what is happening. So it is illustrating how we use the protractor to measure angles. So pay attention as much as possible to see how the protractor is being used when they're measuring angles. And by now, everybody should know what an angle is. I did ask Miss Waysom about what an angle is, but I don't remember she saying it to me. What's an angle again, Miss Waysom?
The 2 lines meet, sir.
That does not describe an angle, Miss Waysom. You have to come better than that. Miss Clark, what's an angle?
Sir, an angle is the degree of opening between 2 lines drawn at a point.
All right, correct. Miss Waysom, that's the correct definition for an angle. All right. All right, so we're going to watch and see what's happening with this video. All right, guys. All right, guys. Let me see the hands of those who understood how the protractor is used based on what you have just seen.
Sir,
All right, Mr. Jane.
sir, I did not hear a word.
Yes, so I was saying that earlier on, Miss Williams, that you wouldn't hear the sound. So I was saying that you should just watch it and pay attention at what was happening. Were you watching to see what happened?
Yes, sir, I was looking.
All right. You have a sense of what she was doing?
Sir, I saw her placing the center of the protractor at the angle.
Vertex. Yeah, that's how it is. And then now the line at the bottom of the protractor must be lined up with that line. Well, you can line it up with the line below or any one of the lines of the two lines that you have. But most likely you would normally line up with the one on the bottom or the horizontal. So you line up that line with that bottom line on the protractor. Then now you would have now counted your angles either by the inner scale or the outer scale. But you use them depending on the situation that you're in. So if you're measuring the angle and you notice that the outer scale is more convenient when you're measuring from 0, then you use the outer scale. Or if you put it from a different angle and the inner scale is the one that is more convenient when you're measuring from 0, that's the one you use. All right, miss? All right, so we would have from these calculated these angles. So now what the task that you would have to do after you have calculated these angles, you would now have to construct the pie chart. And of course, you would have to first use your compass to draw a circle And then now you want to draw a big enough circle so that it give a big picture of how the circle is. So the bigger the chart is, the better the presentation, because you're seeing more clearly what is happening with a bigger chart. So don't draw a little squint up chart with only 20-cent coin or something like that, or $20 coin. That would be too small to show what is happening on with the data. So draw a big enough circle that you can see a clear representation. Then now, how do we now get these angles on that circle? All right, so clearly, you're going to start off with your circle, right? Your circle going to be what you start off with, all right? So you draw your big circle. Now, to start with your angles, the first thing you want to do is to draw one radius. Generally, you draw it from the center to the circumference. Generally, most time it is drawn vertical. So the first radius, you draw it from the center to the circumference. Now, in terms of each of the angles, now you start by measuring one of the angles. So if you choose to measure the one that has 200 and what, was it 6? Then what you would do, using your protractor, just as how they would have shown you in the video, you would place that line with the point at the center, the line of the protractor, and the point, the T of the protractor right at the center. Now, of course, when you look at this angle, it would be greater than the half. So remember that the protractor itself is a half circle, but this angle is much greater than a half circle, because you know that a half circle would give you an angle of what? What would be the angle of a half circle, Ms. Wilson?
Sorry, go again.
What would be the size of the angle of a half circle?
360 divided by 2, sir.
What is that, Ms. Wilson?
180.
All right. So a half circle would be 180. And if you're measuring an angle which is greater than a half circle, then first what you need to do is put the protractor on it, and then wherever the half circle ends, which is the 180, which is generally a straight line when you put it down. So you draw a dotted line going down to show where the half circle would have ended, right? So you know from here to here would give you an angle of 180 degrees. But what you're really measuring is 206. So it means that if here is 180 degrees, how much more you need to get to 206? Ms. Clark, how much more, if you have 180 already, how much more you need to get to 206 degrees?
Sir, is it 20? No, 26?
180 plus, if you take away 180 from 206, how much left?
26.
All right, 26.
Sir,
So it means that this little portion here, you have to measure an angle of 26 to get this angle. So by adding 26 to the 180, so you add 26 to this portion. So the entire angle now from here to here, once you add it, the 180 plus the 26, that now become 206. All right, is that clear? So that's how you would measure an angle which is greater than the protractor, greater than 180. Now, having done that, when you measure to this point, now you would draw your line or another radius here to represent that first angle. Now, from this line, you can start by measuring the other angle, and the other angle would be 111. Now, that is less than the full angle of the protractor. So this would be 111. So you put your line on this radius and you use a scale on the protractor to count up to 111. And then now you mark off this line where that 111 ends. And so you would put in, I did say 111 degrees, all right? And then now the last angle, you should be able to just measure it and get the 43 degrees. If you measure this and it doesn't work out to 43 degrees, it means that your circle is not accurately drawn, because all of these three angles, when you add them up, you should get 360 degrees. So this part here should be 43 degrees when you measure it, all right? And you see, by doing this now, you would have gotten accurate measurement for each sector. So each slice that we have here would be a sector, all right? So the first sector, which is this big slice, would be 106 degrees in terms of the sector angle. The other sector would be 111 degrees, and the smaller sector would be 43 degrees. Now, is it sufficient for us to just write in these angles and leave it like that? Would that tell us anything? Ms. Wason? Would this tell us anything in regards to the data? Just putting in the angles and leave them alone? Miss Clark?
No, sir.
All right, so what do we really need to do here now?
I think you need to go back to the table that you had, sir, and according to how much.
So for the angles for each portion, we need to label the sector for those portions.
Yes, sir, accordingly.
Right, so you would have this, which is 43 degrees, would be the private. Other method would be 206, and buses would be for 111. Now note that we also did a calculation of the percentage, because oftentimes the percentage would give you a sense of what fraction you're dealing with. All right, because generally fractions will help people to get a sense of portions in terms of size for each of these sectors. All right, so this pie chart would have given you a picture, and the angles would give you a sense of the size, and then now the percentage would give you a sense of